Hi everyone, I'm Teresa Cleary. I'm a family nurse practitioner. I'm also a psychiatric mental health nurse practitioner student. Today we're going to be talking about epigenetics and pharmacologic action as it relates to psychiatry. So we are all born with a specific set of genes and DNA. If we had an identical twin, we know their DNA is identical as well, but why are identical twins different? RNA is a single-strand copy of DNA. Epigenetics is a parallel system that determines if a given gene is made into its specific RNA or protein, or whether it is ignored or silenced. Our environment, what we do, what we eat, what we drink, how we exercise, how we sleep, how much stress we have, our exposure to trauma, abuse, and illicit drugs impacts these genes. Our lived experience can silence or ignore these same genes. Recent studies have shown that even our parents' lived experience can be passed down to us in epigenetics through sperm and eggs. So a little bit more about genes. Genes can be turned on and off by modifying the structure of chromatin in the cell nucleus. Methylation or demethylation of histones determine if genes are silenced or expressed, turned off or on. Deacetylation of histones has a silencing effect on gene expression. Methylation and deacetylation compress chromatin, close the molecular gate, and genes are silenced and not transcribed into RNA or protein. On the other hand, demethylation and acetylation do the opposite. They decompress chromatin and open the molecular gate, thereby activating the genes. The activated genes then become part of the personality of the cell. So there are some enzymes that try to maintain the status quo and keep genes quiet for a lifetime. It was once believed gene activation or silence was stable for the entire lifetime. Through epigenetics, we find that circumstances may change a mature, differentiated neuron. We are also learning that the individual storyline of a neuron can change in how they respond to the narrative. As briefly mentioned previously, child abuse, stress, dietary deficiencies, psychotherapy, drugs of abuse, or psychotropic meds that previously silent genes can make them open and turned on. Previously active genes can become silenced or quieted or turned off. Depending on what is happening, this can have a positive impact or a negative impact. While we are still learning more, we are beginning to learn how epigenetics can treat, and mediate psychiatric disorders, including schizophrenia, depression, PTSD, anxiety, and addiction. Scientists hope with further research in epigenetics to one day be able to treat addiction, treat fear, treat chronic pain, and prevent disease progression in high-risk individuals such as schizophrenics. So for example, we know that schizophrenia is a very debilitating disease. If we can catch this person early on in their diagnosis, we can prevent them from getting worse. One mechanism for changing these epigenetic patterns is via DNA methylation by a type of DNMT enzyme called DNMT2 or DNMT3. These DNMT2 and 3 target neuronal genes for silencing that were previously active. Medications aimed at histones and their enzymes may also be helpful in research and treating these illnesses. Questions scientists have include, how does the neuron know which gene to be silenced? This is a very exciting time in epigenetics. It seems like there's great things to come and a lot of opportunities to change their destiny